Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be taking a look at how to expand logarithmic expressions. Don't forget there are some practice problems at the end of this presentation for you to try out, so be sure to watch the entire presentation and do the practice problems. To get started, let's do a real quick refresher on the properties of logarithms that will be guiding our problem solving process. All right. So the first one that we're going to review is the product property of logarithms. So the product property is as follows. Basically helps us to see why logarithms are useful. All right. So if you're multiplying numbers, an easy way to multiply numbers, especially difficult numbers, like decimals, is to take the log. And what the log does is that it converts the multiplication operation into what? Into addition. Okay? So log of x times y is the same thing as log of x plus log of y. All right, so multiplication in the real world is equivalent to addition in the log world. All right, and then the quotient property also helps you to see the benefit of logs. Let's say you're dividing horrible looking decimals, right? So you divide in two numbers, x over y. All you just have to do is take the log of those two numbers and find the difference. All right, so the log of the quotient of two numbers is the same thing as the log of the difference of those numbers. Log base b of y. All right, and then we have the power property. So if you have log base b of a to the x, you can just power down this. It changes exponentiation into multiplication. So x to the log base b of a. All right, so it just powers down the exponent, changes it from a power into a factor that you're multiplying the term by. All right, and then the last one, this one basically serves the purpose of simplification. Inverse property. If you have a situation where the base of the log and the base of your exponents are identical, then you have a cancellation action happening since they're inverse operations, and you're just left with the value of the exponent x. All right. Okay, so just a side note that this is one of the properties that we're going to be using. This is known as the nth root property of exponents. So nth root property of exponents. This is a special case. If you have the square root, the nth root of a term, let's say the nth root of x, right, is equivalent to, you can write this radical as a rational exponent, x to the 1 over n. Okay? And in the special cases, if we have, let's say, the square root of x, that's going to be x to the 1 over 2 because there's an invisible 2 right here. All right, so just keep these two additional properties in mind because we're going to be using them in our problems. All right, so the instructions for us are to expand the given expressions. So we have the following condensed logarithmic expressions. Let's start with question number 1. So for problem number 1, let's say we have the log expression, log base 8 of u times v times w to the 4th power. All right, so how can we write that in expanded form? All right, let's rewrite the problem. Log base 8 of u times v times w to the 4th. All right, so we're going to deal with the product first, and then we'll deal with this exponent later. All right, so we have the product of three factors. Using the properties of logarithms, we know that the product of numbers is equivalent to addition in the log world. So these multiplication operations will change to the sum of the log of each factor. Okay, so we have log base 8 of u plus log base 8 of v plus log base 8 of w to the 4th. All right, and then this last term here has a power, so we can apply the power property to the last term and then just power down this power. So it becomes log base 8 of u plus log base 8 of v plus 4 log base 8 of w. And there goes the answer to question number 1. All right, let's take a look at another example. Number 2, let's say we have a quotient situation happening. So let's say we have log base 9 of 11 to the 5th divided by 6, all raised to the 5th power. So the task here is to rewrite it in expanded form. So let's go ahead and write down the problem. So we have log base 9 of 11 to the 5th over 6 raised to the 5th power. All right, so order of process that we're going to be doing here is we're going to do the exponent first, then the quotient, and then the exponent of this numerator term. Okay, so how do we do with this exponent here? It's powered up, so we're going to use the power property to power it down. It becomes a coefficient. So this becomes 5 log base 9 of 11 to the 5th power over 6. Now we're going to shift our attention to the quotient operation. Division of numbers is equivalent to the log of the difference, right? So we're going to have 5 log base 9 of 11 to the 5th power. And this division becomes a minus. And don't forget, this 5 is being multiplied by the entire thing. So we distribute it across. So we have 5 log base 9 of 6. And then lastly, this logarithmic argument 11 has a power of 5. So we can apply the power property again and power down this 5. It's going to be multiplied by the existing 5 over there. So when you execute the multiplication operation, you have 25 log base 9 of 11 minus 5 log base 9 of 6. And there goes your answer to question number 2. All right, let's try another example, question number 3. So for question 3, what if we have the natural log of c times the cube root of a times b? All right, so we can see that a portion of the logarithmic argument is being rooted. All right, you're taking the third root of that. So let's see how that works out. All right, so let's write the problem again. So we're looking at the natural log of c times the cube root of a times b. All right, so let's look at a sequence of operations we're going to be carrying out. So first of all, we're going to do this multiplication operation, which will split c from this root. And then we're going to attack the cube root using the product, using the power property, and then we'll proceed to attack the multiplication of these two in that order. All right, so let's do this multiplication first. So just know that ln, natural log, is the same thing as, so ln is just the same thing as log base e. All right, log base a natural number e. Okay, so just keep that in mind. So the same principle applies here. So the multiplication of numbers in the log world is addition, right? So we can write this as the natural log of c plus the natural log of the third root of a times b. Okay. All right. Now, how do we write this as a power so we can power it down? We're going to use the nth root property that we talked about earlier and write it as a rational exponent. So it'll be a times b raised to the 1/3 power. Okay. Now we have the freedom to use the power property to power down this exponent. It's going to become a coefficient. So we're going to have the natural log of c plus 1/3 of the natural log of a times b. So to finish this off, this multiplication operation of a and b in the log world is equivalent to addition. So finally, we're going to have the natural log of c plus 1/3 of the natural log of the first factor, which is a, plus. Now, don't forget this 1/3 will be multiplied to the two terms that we're adding. All right, so we'll distribute it across. It's going to be 1/3 of the natural log of b. All right, so there goes the answer to question number 3. All right, 2 more problems before we give you some practice problems to try out. All right, so for question number 4, let's say we have log base 9 of the third root of x times y times z. Okay. All right, so let's do this. So for this one, in order to gain access to x times y times z, which is being rooted, we need to take care of that rooting operation, which is the third root. We need to take care of that, okay? So how do we rewrite the third root using the nth root property of exponents? Well, can you write it as a rational exponent? So log base 9 of x times y times z. We're going to raise it to the 1/3 power. Okay? Now we're in a position to power down using the power property of exponents. Power down that power right there. So that becomes 1/3 of log base 9 of x times y times z. Okay, so now how do we apply the product property here? You remember the product of numbers is equivalent to taking the log of the sum. So this products will become sum in the log world. So we're going to have 1/3 of log base 9 of the first factor x. Multiplication becomes a plus. Distribute the 1/3 across. 1/3 log base 9 of y. Okay. This other multiplication becomes a plus. Distribute the 1/3 log base 9 of z. There goes the answer to question number 4. All right, let's try out one more problem. This one's a little bit more involved before we give you some practice problems, okay? So natural log of 3 divided by 7 times 10 to the 4th, all raised to the 2nd power. So the goal here is the same as before, which is to write it in expanded form. All right, so let's rewrite the problem. Natural log of 3 over 7 times 10 to the 4th raised to the 2nd power. Now what we're going to do first is apply the power property to power down this exponent, okay? So power that down. And then we're going to have 2 times the natural log of 3 over 7 times 10 to the 4th. All right, so we've powered down the exponent. Now we have division here. We're going to do with the division first, and then this multiplication and this power in that order. So division in the log world is equivalent to subtraction. So this becomes 2 times the natural log of 3. Okay, minus, distribute the 2 across, 2 times the natural logarithm of the denominator, which is 7 times 10 to the 4th. All right, so now we have a multiplication operation we're going to focus on next. This multiplication in the log world is equivalent to addition. So we have 2 times the natural log of 3 minus 2 times the natural log of 7 plus, and then we're going to distribute this -2. Okay, so this is going to become a minus 2. It would have been a plus before. All right, you know what? Let's do this. Let's introduce an intermediate step so that you can see what's going on. So just put a parenthesis here. Let's write it again. So let's say we have, because this negativity here introduces an additional level of complexity. So negative 2 times the natural logarithm of 7. So it changes times to a plus the natural logarithm of 10 to the 4th. Okay, so you can clearly see that this times becomes a plus. We have this negative 2 out here. What are we going to do with it? Guess what? We're going to distribute the entire negative 2 to these two terms. When we do that, observe what happens. It becomes 2 times the natural logarithm of 3 minus 2 ln 7 like we had before. Now this minus times this plus, we multiply different signs. It becomes a minus 2 times the natural logarithm of 10 to the 4th. Okay? All right. And then lastly, we're going to apply the power property to power down the power that's attached to the logarithmic argument of the last logarithmic term. So power down this 4. Okay. And then you get your final answer, 2 times the 2 log 3 minus 2 times the natural logarithm of 7 minus, now there was a 2 here before, so you just multiply the 4 by the 2, so you get 8 times the natural logarithm of 10. So there goes your answer for question number 5 in expanded form. Okay, so let's give you some problems to try out. All right. So here are 6 practice problems that we will like you to try out. So go ahead and pause the video presentation at this time and try these problems. When you're done, click on the playback button and we're going to reveal what the correct answers are. Alrighty, so here are the answers to questions 1 to 6. Go ahead and check your work. So how well did you do in the practice problems? If you got them all right, go ahead and destroy that like button for us. If you had any questions about any of these, you had any confusion, just specify it in the comment section below and we'll be more than glad to assist you. Thanks so much for taking the time to watch this presentation. Don't forget to support our channel with your likes, comments, and subscription. Tons of support resources at mathgotserved.com to check it out. Thanks again for watching. We'll see you in the next video. Goodbye.